Hello everyone. Today we'll be discussing another multivariate technique which can be used for some sort of dimension reduction, and that is factor analysis. Now there are many similarities in PCA and factor analysis, hence people are many a times confused whether to use factor analysis or principal component analysis. See, the initial setup is actually different in those. So in PCA what we did was, we had some variables with us, say x1, x2, xp, and using those variables we tried to get some linear combinations which we called as principal components. Okay, and those linear combinations helped us in understanding the data more. Okay, but originally, of course, our variables of interest were the variables that we have recorded, that is x1, x2, xp. However, factor analysis comes into picture when we have a completely different scenario. So the main assumption of factor analysis is that we have more interest in some unobserved variables which are known as latent variables. Okay. So generally the variables which cannot be measured. For example, actual intelligence. So IQ is kind of a proxy for actual intelligence, but actual intelligence cannot directly be measured. When I say intelligence, the same thing applies to the factors of intelligence, like say we can say computational abilities of a person, or linguistic abilities of a person, or we can say emotional intelligence, etc. So again, none of these components can be directly measured. So we use different tests which can possibly act as proxy for these. Okay. Even in the case of other things, like for example, you can have say latent variables or factors like strength of a person. So what do you mean by strength? I mean, quantifying strength is difficult. You can't quantify it, you can't measure it directly. Okay. Or say resistance of a person, etc. Even in the case of product, these things can go. Okay. So you may have some concrete formula for strength if it's something as simple as a thread. But if you have a product like say watch, so when you say strength, you may have to consider various things. So you may have to consider the fact that it shouldn't break when it is thrown from a height. At the same time, it shouldn't break when it is dipped in water, etc., etc. And combining all those things, you are going to quantify what is known as strength. Okay. So whenever you are in such a scenario where your actual interest is in knowing more about latent variables which are generally non-measurable or not directly observable, easier word would be not quantifiable directly, then in such scenarios factor analysis is used. Okay. So as I said, there is a difference in the initial setup. In PCA, there are no such unobserved variables. In PCA, you are interested in those things which you are anyway observing. After getting those things, you are trying to combine them so that you can summarize them. However, in factor analysis, our major interest is in unobservable latent variables. Okay. Now, these latent variables are then expressed in the form of a mathematical equation. Okay, so what we do is, okay, I don't know intelligence, but then I try to think what are the other things which I can measure and which may be related to intelligence, so that the values of the measured things can give me some idea about intelligence. Okay, so what we do is, we observe related quantifiable variables. Okay, we observe other variables which are related and which are quantifiable. So observe related quantifiable variables which are generally affected or controlled by the unobserved variables which are of interest to us, which are generally affected or controlled by the latent variables. Okay, so for example, as we said, IQ would then be a quantifiable variable which can be observed but which is basically driven by actual intelligence. In fact, not just IQ, various components of IQ. So, test score on a non-verbal ability test. Okay, non-verbal mental ability test. This can be one component. Then, test score on a verbal ability test. This is again something which is observable and which is affected by the unobserved things. Or test score on psychometric analysis test. So these are the things which we are going to observe. Okay. When we talk about say strength, ability to lift weight. So how much weight can be lifted, or how much pain can, again pain is non-measurable. So in fact that can become a latent variable. So how much weight can be lifted, or how long can person hold a weight steady, etc. Okay, so what we do is we observe these related quantities which are actually controlled by the latent variables, and then we try to frame a mathematical equation which can relate these observed and unobserved variables, and then through that equation we try to get more insights into the latent variable. Okay, so what would be the, when I say mathematical, I of course mean statistical because there is a random component. So what would be the mathematical or statistical formulation for it? So these observed variables we will denote by x1, x2, xp. So these are observed variables which are measured, but we are not actually interested in them. We are interested in something else. We are using these observed variables to reach to the things in which we are interested. Okay. So the latent variables we would generally denote by f1, f2, fk. These are the latent variables which are actually of interest to us. Okay, and k is strictly less than p. As I mentioned, latent variables are of interest, and factor analysis is again kind of a dimension reduction exercise. So we are going to assume that we have a set of few latent variables which affect and control many observed variables. And there is no one-one relationship. Means what? So if I have say f1, f2, fk, and if I have x1, x2, xp, then many of these latent variables might control or affect many of these. Okay, so I might have f1 going to this and this. f2 might be controlling say these 3 mainly, or 4, something like that. Okay. So for example, if I continue talking about the IQ thing, so let me write down the test scores that we have. So we have say verbal mental ability. Then we have say non-verbal mental ability. Then we have logical reasoning score. And we have say linguistic ability score. So suppose a person gives these types of tests, and we have here we have actually the factors. So the say emotional intelligence, language or basically linguistic intelligence, then we have mathematical intelligence, so emotional intelligence is going to have some role in linguistic abilities. Okay, you should be able to perceive the emotions of the author to understand it better. Okay, language abilities would of course have a role in verbal mental ability as well as linguistic ability. Mathematical intelligence would have role in logical reasoning, non-verbal mental ability, verbal mental ability because you need reasoning there, and to some extent even in linguistic ability because many a times grammar patterns are like mathematical patterns. If you understand them well, you would be able to express yourself well in a particular language. Okay, so many of these factors might control many of the observed variables. So there is no one-one relationship. Okay, so these things we have to capture, and just like PCA, we try to find factors which are not directly much correlated with each other. Okay, so let me write down the mathematical form of the equation. So it would be x minus mu is equal to qf plus u. Let me try to indicate the dimension. So this is a vector, this is a vector, q is a matrix, f is a vector, and u is a vector. So list out what are all these things and then we'll discuss them in detail. So x is a p cross 1 vector which consists observed variables. Okay. Then mu is actually mean of x. So mu is expected x. Because x has p components, mu also has p components. So mu1 would be expectation of x1. Mu2 would be expectation of x2. In general, mu I equal to expectation of xi. Okay. Then Q is known as a loading matrix and it is of order P cross K. Okay, it's a loading matrix. Then F is a vector of common underlying factors which are also known as latent variables. And U is kind of like error term, but it consists of specific factors. We'll discuss in detail what is meant by that. So U is a vector of specific factors. Okay. Orders of F and U. F is of order K cross 1. U is of order P cross 1. So first let us check in the equation if all the orders are matching. You know, when you studied matrix operations, you must have seen that Not every matrix can be multiplied with every matrix. You have to have some dimension compatibility. So let us see here. My x is p cross 1, mu is p cross 1, so one can be subtracted from other, and overall order of this is again p cross 1. U is p cross 1, so no problem. And then qf is p cross k, and q is p cross k and f is k cross 1, so they can be multiplied, and the final product is of order p cross 1, so it is okay. So order wise we are in not in a problem, so we are in the okay place. Now there are some other assumptions in addition to these. So this is a form of equation, and we assume that all the factors are centered. Centered means their mean is 0. So expectation of each f is 0, so overall expectation of f vector is a 0 vector. Similarly, expectation of u vector is a 0 vector. Then we also assume that the factors are scaled and uncorrelated. So common factors. Let me write as a separate line. Common factors, that is factors in f, are scaled and uncorrelated with each other. Why do we assume that? Because we want to keep number of factors as low as possible. Okay, common factors are scaled and uncorrelated with each other. Now some of you might have started thinking that see, our abilities are related, linguistic and emotional, etc, etc. So originally the abilities need not be related. The scores are related. The scores are correlated because the scores may be affected by a common underlying ability. So a linguistic intelligence can have contribution from mathematical ability also. Hence, linguistic score and logical reasoning score might be correlated because both of them have some contribution from a common factor, which is mathematical ability. Okay, that is what this model tries to say. So common factors are scaled and uncorrelated with each other. Hence, if I write variance covariance matrix of common factors, it becomes an identity matrix. Okay, it becomes an identity matrix, and the specific factors, we say U are specific factors. So specific factors are, they need not be scaled, but they are also uncorrelated with each other. Scaled means their variance need not be 1. Okay, so we write variance covariance matrix of U as a diagonal matrix. So the correlation is 0, but variance values can be different from 1. So variance covariance matrix of U is a diagonal matrix, which generally denoted by psi. So psi is a diagonal matrix. Now what is meant by specific factors? So we are trying to control all these x minus mu values through these common factors f, but so basically we say that variation in all these observed variables xi's we are trying to express through the unobserved factors, but of course there may still be some unexplained variation remaining. So to account for that unexplained variation part, we bring in a vector of specific factors. Okay, hence we actually have t different specific factors, one corresponding to each observed variable. So for each observed variable, whatever is the part which is not explained by common factors, that part we would write in terms of the specific factor which corresponds only to that variable. Okay, so this equation in the mathematical form, it is in the matrix form it looks like this, but we can express it in the individual level also. So let me try to write. If we simplify that matrix form, First let us try to expand it, write it individually. So if we have x1 minus mu1, x2 minus mu2 up to xp minus mu p, then we have a Q matrix which is of order P cross K. So I will have Q11, Q12, Q1K, Q21, Q22, Q2K, QP1, QP2, QPK, and we would have F1, F2, Fk plus we will have U1, U2, UP. Okay. I am just writing the same equation by listing all the components of that equation. Okay. Now, if we try to write down equation for say single variable on left hand side, for example, let me write for x1 minus mu1. It would be by using matrix multiplication rules q11 f1 plus q12 f2 plus q1k fk plus u1. Okay. So if I want to write in general for any jth variable, it would look like xj minus mu j is equal to qj1 f1 plus qj2 f2 plus qjk fk plus uj. Okay. Is it okay? Now we have to see what is the role of qij's. See, in x1 minus mu1, q11 kind of denotes the amount or extent up to which f1 is contributing. q12 denotes kind of contribution up to which contribution of f2. Okay. So if q12 is higher than say q11, it would probably mean that f2 has a bigger role in x1 minus mu1 than f1. Okay. That's why this Q matrix is known as a loading matrix. And through these loading matrix we try to understand which factors affect which variables more. Okay. So because f1, f2 are the underlying unobserved variables, so through these loading matrix we try to see what is the extent of role of each of the unobserved variables in the final observed things. Okay. There are mathematical ways in which you can estimate Q matrix, F matrix, the variance coefficient of the specific factor, etc. So in fact one of the methods is based on principal component analysis, but we won't go into the mathematical details of that. For you, just understanding the model is enough, and then we would use software to implement the model. Okay. But in interpretation, some things are going to come. So for example, using this component wise equation, we can see some more things. For example, if I take variance on both sides of this component wise equation, what do I get? I would get variance of xj minus mu j as qj1 square, because qij's are constant, they are not variables. They are kind of giving you proportion of, not proportion, they are giving you some sort of amount of influence of each factor on each variable. So qj1 square variance of f1 plus qj2 square variance of f2 plus qjk square variance of fk plus Now covariances won't come in picture because we have assumed that fj's are uncorrelated. So I would directly go to variance of uj, and uj is anyway only one uj coming in picture, so no question of covariance. Okay. We have also assumed that the factors are centered, so variance of each fi is 1. Okay. So what I have is variance of xj minus muj, which is same as variance of xj because variance is not affected by change of scale. Okay, because muj is constant. So this is generally denoted by sigma square jj in our variance covariance matrix, the jj diagonal entry. So sigma square jj is qj1 square plus qj2 square plus qjk square plus variance of uj is psi jj. Okay. So if I want to use a further compact notation, this would be sum over qj L square, L goes from 1 to k plus psi jj. Okay, you can see here this sum over qjl square is basically sum of squares of elements from jth row of the Q matrix. Let me repeat, this is sum of squares of elements from the jth row of the matrix. So this is generally known as hjj square. It's just a notation. So this sum is called as hjj square. Why we give square? Because it is sum of squares, so we need to remind ourselves that it is going to be mostly a positive number, 0 or positive, it can't be negative. Okay, so hjj square, psi jj and sigma jj square. So what does this final equation mean? This equation means we know that sigma jj square is variance of xj. So this original variance of xj or variation in xj we are breaking down into two parts. This hjj square is known as communality. Okay, so communality means this is variation explained by the common factors. Okay, so this is variation explained by the common factors, the latent variables, and psi jj is known as specific variance. So this is variation which is unexplained by the common factors, and hence we kind of prepare a special factor to account for that. Notice specific factors are specific to each variable. So you have u1 which corresponds to x1, you have u2 which corresponds to x2, and u1 will not have any role in x2. That's why for a jth variable only jth specific factor comes into picture. Okay, not others. Whereas in common factors everything is coming. So when we write qj1, qj2 etc., you can see that it is kind of contribution of every factor. So variance of f1, f2, fk, everything is coming in picture. Okay. So this is a mathematical model for factor analysis. As I said, we are not going to go into the details of how the values of q and psi's are computed because it is beyond the beyond your syllabus. But we would of course see the interpretations. So in interpretations like PCA, you decide number of factors using the scree plot. Then you see how much variation is explained by each factor, and here you try to give name to each factor. Okay, so after getting the information on latent variables, you try to name. So say first latent variable corresponds to what is our interest, or does the second latent variable corresponds to what is that is of our interest, etc. Okay, so we would see more things when we go for the practical part of this. So on the theory aspect, let me stop here.